Alright, welcome guys to our physics chapter 1. We're going to be running through all chapters on motion. So this is the first chapter. The first question is the internationally agreed system of units. I would like to give notes before I take each questions if there's a note. So let's take down. Right, there are three internationally agreed system of units. 1. Kilogram. 2. Meter. And 3. Seconds. Go to the next line. Right, mass is measured in kilogram, length is measured in meter, while time is measured in seconds. Give a space, one line, and write. Fundamental units are ampere, which measures electric current, Kelvin measures temperature, moles measures amount of substance, and candela is spelled Candela, measures luminous intensity. Now let's go back to our question. The internationally agreed system of units, SI, or they call it SI unit, for physical measurements are, the correct answer is kilogram meter per second, option C. Next question, let's take down this note. While a spring balance operates, a spring balance operates on the basis of Hooke's law. Next line, a beam balance operates on the principle of moment. A spring balance operates on the basics of Hooke's law. Then at the front of it, open bracket, measures weight. Next line, right, a beam balance operates on the principle of moment and it measures mass, full stop. Let's go to question 2. To determine the weight of an object, you use a spring balance. Number 2 is option B. Number 3, which of the following physical property is not a vector? I want us to write down the next couple of stuff, right? Mass, right, scalars, then under you write mass, length or distance, speed, time, area, volume, temperature, pressure or pressure, density, power, energy, work, electric charge, electric potential. Those are examples of scalar. Give like 2 lines and write. Vector, e.g. weight, force, displacement. Next, velocity, acceleration. Next, momentum. Next, moment. Next, torque. Next, electric field. Next, magnetic induction. And lastly, magnetic flux. So let's come back. Which of the following physical quantities is not a vector? Do not forget that weight and force, they are vector. Work is definitely a scalar. Work is not a vector. So number 3 is option B. Work is a scalar. So which of the following physical is not a vector? Force is a vector. Electric field intensity, please add it to it. Electric field intensity, and also add magnetic induction to your notes. They are part of vector. Velocity also is a vector. Force is a vector, but work is a scalar. Number 4, an example of a scalar quantity. We've touched this one already. You could pick the answer yourself. I'll just pick the answer and run. Electric charge, option C. Number 5, one of the following readings represent, the reading is not actually shown here, so we'll skip that for time's sake, so we'll be fast. Okay, I need to zoom in a bit. We'll continue. Number 6, which of the following is not a vector quantity? Which of the following is not a vector quantity? Force is a vector. Weight is a vector. Displacement is a vector. Acceleration is a vector. Altitude is a scalar quantity. So right, altitude is a scalar quantity. So number 6 is altitude. And what is altitude? Right, altitude equals vertical distance. A vertical distance is what they call altitude. 7, of the following derived units, the one that is not a unit of power is, I would like to answer this question with demonstration because I will need to derive the formula. So we'll skip through this. Number 8. For which of the underlisted quantity is the derived unit ml? This is dimension and dimensional analysis. I'll need to touch this one also, demonstrating it. Number 9. Which of the following is not a fundamental SI unit? Is not a fundamental SI unit. Radian is not a fundamental SI unit, right? Radian is a dimensionless unit and could be regarded as a derived unit. So it is not a fundamental SI unit. 10. Which of the following statements are true about the okay, let's go a bit down. That's good. Which of the following statements are true about spring balance and chemical balance? Do not forget, spring balance measures weight, chemical balance measures mass. So you would go through, let me see, no, option A. So both are used to measure mass. This is not, which is not true. This one is definitely not true. These both are used to measure the mass of an object. No, one will measure weight. Spring balance measures weight, beam balance measures mass. Either of them may be used to measure the weight of an object. Either of them. Now, the spring balance works on the principle of Hooke's law, correct? While chemical balance works on the principle of moment. Now, number 4. A change in gravity changes the reading of a spring balance, definitely, but not that of a beam balance. So you need to pick now. Not option A, not option C. The spring balance works on principle of Hooke's law, while chemical balance works on the principle of moment. So we'll go back to our question. Which of the following statements are true? Option C, I, and IV. Number 11. Which of the following represent the correct precision if the length of a piece of wire is measured with a meter rule? I would also love to demonstrate this with a video proper. 12. Which of the following is a derived unit? Which of the following is a derived unit? Newtons. Option D is a derived unit. 13. Which of the following unit is equivalent to? I'll need to demonstrate this one also. So we'll go to the next question. 14. Which of the following are the correct SI units of the quantities indicated? So we have force, we have torque, we have watts, and we have momentum. Which we are asked for the correct SI units. Let's see. The unit of force is in Newton, I, and the unit of power is in watts. So option D is correct for number 14. 15. Which of the following quantities are scalars? Scalars quantity. 15 is option IV. Kinetic energy is a scalar, and also electrical potential. All potentials and energies are scalars. Do not forget, right? All potentials and energies are scalars. So number 15 is option D. 16. Which of the following is a set of vector? Force is a vector, mass is a scalar. No. Acceleration, velocity, and moment. 16 is option B. Option B. 17. What is the reading of a vernier scale above? The vernier scale wasn't given to us, so let's put a stop there. Okay, the vernier scale here was given, but I would love to demonstrate this so that it will be much more clear. This video will be strictly based on theory. We'll treat theories here. 18. Which of the following is a fundamental unit? Seconds. Option D. 19. What is the least possible error in using rule graduated in centimeters? I would also love to show you this, but the answer is option A, least possible error. 20. Which of the following quantities has the same unit as watts? Quantities having the same unit as watts is option D, force and velocity, because force times velocity. I might also need to demonstrate the answer of number 20 with a different video. 21 is definitely a bit of calculation. 22 similar. 23 same. 24 same. 25. The physical quantity that has the same dimension as impulse is momentum. So 25 is option B. 26. The inner diameter of a small test tube can be measured accurately using, please let's jot down, Vernier caliper is used to measure the diameter of a tube or a rod. Next line, right. Micrometer screw gauge. It is spelled micrometer is spelled MICROMETER. Screw is SCREW. Gauge is GUAGE. Micrometer screw gauge measures smaller lengths such as thickness of paper, diameter of a wire or pendulum bulb. So let's go back. The inner diameter of a small test tube can be measured accurately using 26 is option D, pair of vernier caliper. 27. Which of the following consists entirely of a vector quantity? Which of the following consists entirely of a vector quantity? Do not forget work is a scalar. Work is a scalar, so it's out of it. Displacement is a vector, impulse now. 27 is option A. Right. Velocity, magnetic flux and reactions are vector quantities. 28, we need to demonstrate that. 29, the pair of physical quantities consisting of vector only are vectors only is option B. Displacement and torque are vector. Do not forget magnetic flux, reaction, torque, they are all vector. This torque, TORQUE, is called torque. 30. The correct unit of energy density is, I'll need to demonstrate this also. 31, dimensional analysis. 32, you have your force, torque, current, and power. Which of the above are the correct SI units of the indicated power? Power is given in watts. So 32, power is surely given in watts. Okay, force is in Newton, correct. I. Current is in ampere, correct. And IV. This is not the correct SI unit of torque. 33. Which of the following is not a vector quantity? Altitude. This question has been repeated. So question 40 is option A. Question 33, is option A. Here is it. Here is option A. Would go further to tackle the questions. This will be solved for us. 35. Diameter of a small ball bearing. Thickness of a piece of paper. Diameter of a small ball bearing. Diameter of a measuring cylinder. Next, length of a piece of wire. Which of the above can be measured using a micrometer screw gauge? First thing that will come to your mind is this small ball bearing and thickness of paper. Those I and II should come to your mind. Remember, I gave you what you use micrometer screw gauge to measure. So let me see through I and II. Option B is the correct answer. 36. In order to remove the error of parallax when taking measurements with a meter rule, the eye should be focused vertically downward. Option C. 36 is option C, vertically downward. 37. The pair of physical quantities that are scalars only are volume and area. Surely option A. Right. Momentum, displacement are all vectors. Full stop. So 37 is option A. 38. What is the least possible error encountered? This will be demonstrated to 39. A quantity which requires magnitude and direction to be specified is displacement. A quantity that requires magnitude and direction to be specified is displacement because it's a vector. 39 is option B, displacement. 40, electrical potential. Torque is a vector. Potential are scalars. Energy are scalars. Momentum. So which of the following quantities are vectors? Torque and momentum. I and IV. Option D. 40 is clearly with torque and energies. Energies are all scalars. Do not forget, I say energies are scalars. Energies, work, power, they are all scalars. While moment, torque, momentum, they are vectors. So II is a vector, IV is a vector. So number 40 is option D. 41, I'll need to demonstrate it differently. The question actually stopped at 45. 46. An instrument which accuracy is 0.0. I will demonstrate this one too. The dimensional analysis demonstration, all of them here will be demonstration. Now, if you've gotten to this point, the first thing you will do for me, snap the note you were able to jot down. Snap that note and send to me for verification. Once that is done, I would grant you a test on this same chapter for you to take. And also, if you have questions, you could ask your question. If this is your first time coming across our video, please note that we run a private mentorship class on WhatsApp. If you'd like to be part of the class, I'm going to drop the link to the WhatsApp group in the description box of this video. Thanks for watching. Do not forget, if this is your first time also, do well to subscribe to the channel. The more you click on the subscription button, the more they will recommend this video for other students too that would get to come across it and also learn. You could also leave a like. Thank you, and I'll see you in the next clip.